section, we will be doing an example using what we learned from last section, binomial probabilities. The question is asking us, we have 10 independent coin tosses, and we're given that the probability of heads is p, and the probability of tails is 1 minus p. So event A states the first 2 tosses are heads, and event B states 3 out of the 10 tosses are heads. The questions we are asked is, what is the probability of A, what is the probability of B, and what is the probability of A given B. So my first approach is to find what we are working with. Using the details given to us, we are given a fixed number of trials. There's 2 possible outcomes, which is just heads and tails. There are independent trials, and we know that there's constant probability. This does perfectly fit with the criteria of using binomial probability. This is because we know that it is used to calculate the probability of observing a number of successes in a fixed number of trials. For 1, what is the probability of A? So event A is the first 2 tosses of heads, and using the binomial distribution formula, n is the total number of tosses, which is 2, and we're choosing 2 of them because we know that first 2 are heads. And following that formula, let's go with P. K is the number of heads we get, which is 2. Q is just tails, which is 1 minus P. And if you do n minus k, that's 2 minus 2, which is just 0. So to choose 2 times p squared times 1 minus p to the 0, that's just p squared. Because 2 choose 2 is 1, and 1 minus p to the 0 is 1. So it's just p squared. So what is the probability of event B? 3 out of the 10 tosses are heads. So we know there's 10 heads. I mean, not 10 heads. 10 total tosses. 3 out of the 10. So we're choosing 3. And the number of times we get heads is 3. 1 minus p. Then it's just n minus k, which is 7. So let's move this to the side. That's event B, by the way. So this is number 1, and this is number 2. What is the probability of A given B? Let's make that easier for us. So, and we do that through conditional probability, and that states that the probability of A given B equals to the probability of A and B over the probability of B. We already figured out the probability of B from number 2, so let's figure out the probability of A and B. Reading the 2 events, we know that the total tosses is 10. So let's draw 10 lines. And remember, we have to meet both criterias. So the first 2 tosses are heads. Let's write 2 heads in the beginning. And we need 3 heads out of the 10 from event B. But the thing is, we don't have the specific location of the third heads. So we're going to have to use binomial probability. And to do that, we have to use the total number of slots left and how many heads we need. So which is just A choose 1. And finishing it off, times p to the 1, 1 minus p to the 7. And that is the probability of A and B. Oh, forgot about the p times p, which is p squared. That is the probability of A and B. So using that, let's finish off with let's move everything to the bottom here. Let's rewrite everything. Rewriting over the probability of B, which we know is 10 choose 3 times p cubed times 1 minus p to the 7. And to find the common factors, let's get rid of the 1 minus p to the 7, 1 minus p to the 7. P squared times p is just p cubed, so let's get rid of that. And 8 choose 1 is 8. 10 choose 3 is just 120, so that is the answer. We'd like to thank you for watching our 5-part series. I hope you enjoyed and felt more knowledgeable throughout our videos. Stay tuned for more, and I'll see you then. Bye!